Very good morning. Welcome to the MOOC course on Applied Multivariate Statistical Modeling. Today is the first lecture. Today, half an hour, we will discuss on Introduction to Multivariate Statistical Modeling, which will be completed in 2 hours. Today's contents include introduction, variables and variate, multivariate situation, statistical models and modeling. In subsequent 3 lectures, we will elaborate on the introductory part. And in the first week, there are 6 half-an-hour lectures. And after 4 introductory lectures, I will start univariate descriptive statistics for 2 half-an-hour lectures. So total 6 lectures in this week. And in total, there will be 60 lectures plus some supplementary lectures. I'm sure that you will be happy with these particular subjects and you will be learning a lot. And in today's data-driven decision-making arena, or other way I can say the data analytics era, this subject is of enormous importance. So I request all of you to be very, very attentive in the lectures, as well as practice all the assignments, submit them in time, and also whenever possible try to read different books on applied multivariate statistical modeling. Your basic requirements are something like this. You know that basic statistics is very important. You know, to understand the multivariate statistics and the related multivariate models. And I'm sure that some of you might have gone through the probability and statistics introductory subjects earlier. If not, I have some lectures on basic univariate statistics, followed by multivariate statistics, followed by multivariate models.
Applied multivariate statistical modeling. So let us define word by word. First is applied. Now what do we mean by applied? In science, there is pure science and applied science. Pure science we generally understand, which is basic science, which is basically talks about laws, theories and their development Definitely it links with the phenomena which we usually observe in different aspects of our life. Now applied science actually uses the knowledge of the pure science and develop something for the benefit of the mankind. So applied science, one of the benefit we can say, then when you talk about engineering it is basically applied. Now when I talk about applied statistics, what do we mean? I am assuming that you have knowledge on preliminary basic statistics, for example normal distribution. If you know normal distribution, then also you know the probability density function f x, which is 1 by root over 2 pi sigma square e to the power minus half x minus mu by sigma square, where x varies from minus infinity to plus infinity. Now, this is the so called this bell shaped curve, which is developed by Carl Frederick Frederick Gauss. The theoretical development. So, there been development of these type of distributions, it is coming under basics. Now, suppose if I want to apply this knowledge to a real life situation, I can find out a situation like this. For example, let us there are three processes, process A, B and C. Take certain inputs, convert into value added outputs, all cases. Let there are basically three identical machines which is producing steel washers. Steel washers will be shaped like this, where there is inner diameter ID, there is outer diameter OD, as well as there will be certain thickness of this washer. So, I can say TH. Now, if you produce a large amount of steel washers, that means the number of items produced is large, N is large, then suppose the quality characteristics or the characteristics of the steel washer which is of important to the people, the customer, this is ID. If you plot, you may get this type of distribution which is normally distributed, and where you will be getting mean here, and there will be definitely standard deviation for ID. Similarly for OD, similarly for thickness. Now, then what you are doing by what is applied here, a production process A, for example, in this case which is producing steel washers, is converted into a statistical process in the sense in terms of a distribution like normal distribution, where we are saying that the production process can be interpreted, the behavior of this process can be interpreted like this. Now, in order to get it further clarified, if we do like this, suppose this one is for A, production process A, and if I say this is for production process B, and third one is this one for production process C, then using these things you will be able to compare A, B and C is their performance in terms of mean and standard deviation. There is possibility also to see that whether the mean ID produced by C is equal to that of B or A, this type of comparisons and other things possible. So, when we develop something which will be useful to the society for the mankind, then we say it is applied. So, now come to the second word, which is basically multivariate. Now, in order to understand multivariate, you have to understand what is variable. I think it is known to you that variable is something which takes different values. That sense I can say takes different values. For example, if I say ID, x is ID, inner diameter, then if I produced one item, I stands for the item, suppose first item, and the ID value, it may take value x1. When you go for second washer, then it may take x2. So, if I such way, if I go for n washers produced, that xn will come into consideration. So, these are the values. So, id takes different values, as a result id is a variable. Now, in statistics we basically talk about two types of variable. One is fixed variable, another one is deterministic random variable. So, fixed, other way we can say deterministic, and random we can say probabilistic. For example, if I create another variable which is month, it varies over year. So, but we know all the months. Suppose what will be the next month? If this month is your December, next month will be January, it is known with certainty. So, it is a deterministic one. But in this case, when you are going to produce the second lot, suppose in the second lot, even in one lot, what is the value of id for the second item or second washer, it is not known with certainty. It is governed through probabilistic distribution. So, that sense that it is a random one, we do not know the value exactly, and this value is coming based on certain random experiment, in this case the process which is producing this item. So, if I go on saying like this, then other variable here is OD, similarly other one is our thickness. Now, in order to accommodate more than one variable, we will write this x1 is id, x2 is OD, and x3 is x1, x2, and x3 is thickness. Then for the first item or was produced, then this will be x11, second one x21 and n1. Similarly, for OD x12, x22 like xn2, and if I go for the x3 variable, that is for first observation it is x13, second one x23. So, like this xn3. So, what we are trying to say here, that we are considering three variables x1, x2, x3, which are nothing but the characteristics of the steel washers in this example, which has inner diameter, which has outer diameter, which has thickness values. Now, if you produced n number of washers, then what will happen? Every washers will be having different values for id, OD, and thickness. Okay. So, this is my observation. First one is observation number 1, second one observation number 2, like there is observation number n, and you see in observation number 1, if I consider only id, that value is x11. If I consider all three together, the value observation 1 takes values x11, x12, x13. Okay. So, similarly, if you go on increasing the number of variables up to xp, then here it will be x1p, x2p, like this xnp. Now, each of these as well as these are observations on multiple variables. Observation on multiple variables. What we want to define here? We want to define here multivariate. Okay. So, in order to do so, we know variable, deterministic variable, probabilistic, that is random variable, and this is one example where every observation is measured on several variables. Then when multiple variables come into picture, then each observation is a variable vector. For example, if I take the ith observation here, then xi will be x I1, x I2, like this x ip. So it is a variable vector, that is ith observation on p variables. So when we deal with this type of situation where our observations or each of the observations have multiple values, each of the observations has multiple values, in the sense values on multiple number of variables more than one, then the situation is multivariate situation. Multivariate situation. Now, we define variable, we define multivariate situation. Let us understand what is variate then. Getting me? So, instead of saying that xi is like this, if I create something different based on all those observations, that there is linear combination of variables. For example, here in this in our example there are three variables x1, x2 and x3. If I create a combination, linear combination LC, which is beta 1 x1 plus beta 2 x2 plus beta 3 x3. So, this combiningly will give a quantity or a value, or other way we can also say a variable, which is, we are saying linear combination of variable which is variate. This is variate. And then what is the definition of variate? Linear combination of variables with empirically determined weights. So, that means beta 1, beta 2 and beta 3 will be determined based on observations. There are n observations, so we will be able to determine all those values. So, linear combination of, or weighted linear combination of variables where the weights are determined empirically, that is variate. Now, in this case, you can go for one variable, simple one variable. That means, if I say there are p variables, we are going for one variable p equal to 1, then that will be univariate. When we go for p equal to greater than equal to 2, that is multivariate. That is what multivariate. Okay. Usually in statistics books you will be finding univariate statistics. For example, in terms of normal distribution, univariate normal distribution, bivariate normal distribution, multivariate normal distribution. So, although bivariate is a part of multivariate, we basically talk about when univariate means p equal to 1, bivariate means p equal to 2, multivariate is p greater than equal to 2. So, this is what is multivariate. By word multivariate, we definitely talk something about linear combination of variables where more than one variable is there and there are multiple observations, not a single observation, n number of observations, and weights will be determined empirically based on the observations, n observation that will be collected from the population where for which we want to infer something. All those inference other things will be discussed later on. Okay. So, the third issue is statistical. Now, what is statistical? By statistical we want to say that it is basically using statistics. That is what we want to infer. So, whatever you are developing something using the statistical tools and techniques, then this development is statistical development. Okay. Now, what is statistics? If I say that statistics is nothing but collecting, then organizing, then analyzing, representing, and interpreting. What I mean to say? Collecting data, organizing data, analyzing data, representing the results and interpreting the results for the population for which the statistical model or the statistics is used. It is a purposeful, some purposeful work will be served. So, we when we talk about statistical, so that means we talk about a population, then a sample consists of data from the population, and we have some purpose in our mind, objective in our mind. We want to infer something from of the population, and we collect data accordingly. We organize the data, we analyze the data, then we find the results. That result we summarize, and based on this summarization, the key findings we infer about the population. So, that is what is that is what the word is statistical is used. Now, last word, but very important one is the modeling. Modeling, if you want to understand, then first you understand model. The model, there are many types of model. Actually, very simple one is in our school days, I can remember we talk about a spring balance like this. So, where happened? This is a spring, a elastic one, a load is attached with this P, and it behave in some way. That behavior if you increase the load, the elongation here will be more. If you reduce, it will be less. So, this is a behavior, this is the spring balance model. So, in order to show the behavior of the spring, this type of physical model are developed. So, this is one model which is basically a physical model, which is a physical model. Okay. Now, same thing, when I came to my engineering studies, I found that there is one important concept called or development or theory called Hooke's law, where that sigma, the stress developed on the spring, and the elongation and strain developed on it, they are modeled in such a manner that there is a relationship like this, and this is the range of elasticity. There is another concept of elasticity. So, what I have seen there, or we all have seen there, that sigma varies as epsilon. So, sigma is E epsilon, where E is Young modulus or modulus of elasticity. So, this is what is the theory behind the for behavior of elastic body when the load is so developed that each will not go to the yield point or beyond end point, that inelastic zone. So, so long the body is stressed within the elastic limit, what will happen? The property that if you remove the load, that means it will recover back to the original position. So, this type of development is possible because the physics of this particular issue that spring is known, and we can say if I know the modulus of elasticity, I will be able to tell the relationship between sigma and epsilon, and that time in engineering mechanics and strength of material subject we learn all these things. This is a mathematical model. So, in reality you will get different types of mathematical model. So, that means what I mean to say here, that a physical model, a mathematical model. Okay. Now, what will be the statistical model in this case? For example, you take a case, I think in the beginning of the this particular study, for example, the Hooke's, how did he develop all those things. So, perhaps through experiment, I have no idea. But suppose you don't know the modulus of elasticity, but you know that is a elastic body, and you want to find out the relationship. In that case, you can do an experiment with sim p varying p from p1 to pn. So that means you will create n different combination, then you will be getting 1 to some n observations, and sigma and epsilon values you will be getting sigma 1, sigma 2, sigma n, they have epsilon 1, epsilon 2, and then epsilon n. Okay. So now if you plot this, what will happen? You may get a plot like this. Here it is sigma and epsilon. Essentially, what is the difference between this and this? Here what I am saying, I have straight away without when you have shown me this spring balance, then I immediately say that it is elastic body. If it is elastic body, this is the diagram, because I know the physics, I have this Hooke's law is known to me. So mathematics is known to me, I am showing. But in case it is not known, I have done several experiments here, and based on this I am able to plot like this. Need not be the perfect straight line you will get when you go for empirical modeling. So this is what is the empirical one model. So this empirical model, when you talk about empirical model, are like this experiment based or data based models like this. These are basically using statistics, these are all statistical. This is, so for me this is your, or for all of us, this is our statistical model. Okay. Now what is modeling then? Modeling is basically you want to get this type of results. It is not that immediately you will get all those things. There is a process, steps. I have to understand what is my purpose. I have to understand, in order to fulfill the purpose, what are the different variables they are affecting there, and I have to identify all the important variables. Then I have to see that how the data on the variable will be collected. For example, here I have shown you the experiment, but it may so happen that that you cannot do the experiment. So in that case, is there any other way of collecting data? For example, naturalistic observation. Someone is interested to see the behavior of a particular animal. So he cannot do experiment, maybe that is a wild animal, but there are a large number of wild animals of that particular species. So we can observe the behavior, just going and observing, field based. So okay, so field based observation. Our this one is our experiment. Sometimes what happened, we will go for some naturalistic observations, which I talk about the wild animal case. Field based observation mean the production. You go, suppose the steel washer case, you go to the production shop and see that what is happening there, collect data, and accordingly you do some modeling, naturalistic observations. So all those type of data collection mechanism comes under empirical modeling, and you have to understand all those things. So there is this process, the process of modeling. Then the process of model building is called modeling. The process of model building is called modeling.